Hi friends, we're going to jump into example 4, unit 5, day 1 notes. This one we're going to be solving using elimination. First thing you want to make sure is that they're written in standard form. This one is a little bit tricky. The first one is, but that second line, notice it says 6y, so we need to actually write it so that 5x is first. I'm going to rewrite the whole thing, however. So I have 2x minus 3y equals 7, and then in the bottom here, 5x plus 6y equals 4. So again, using the left brace to denote that. So I'm going to solve these systems using elimination. So I want to make sure that with elimination, when I combine these, when I add the rows, add row 1 and row 2, that using vertical addition, that one of the variables eliminates. It does not. In fact, if you look at it currently, what's going to happen is I would have 7x plus 3y. So then I look to see if one of the variables, coefficients, is a multiple of the other. 2 and 5, that doesn't work. However, negative 3 and 6, they are, and in fact, if I multiply the first row by 2, now I see the entire row. If I multiply the entire row by 2, then what I end up with is something that when I add it to the 6y, because I'll have negative 6y here, when I combine those, I will have no y, or 0y. So 2 times row 1 is equal to 4x minus 6y, and then if I multiply 2 times 7, I get 14. Notice the notation that I'm using for this. Row 2 just comes along as it is. So that's 5x plus 6y equals 4. And then with vertical addition, when you combine them, so I'm going to have 9x, 0y equals 18. Divide by 9 on both sides, and you get x equals 2. Now what do you do with this x equals 2? Well, you back substitute it into any of the equations to find out what the variable, to find out what the variable y, to find out what y is. So I can pick any of them that I choose. I'm going to pick this one here. So if I take 2x minus 3y equals 7, plugging in 2 for x, so I have 2x, 2 times 2 minus 3y equals 7, 2 times 2 is 4. Subtract 4 on both sides, get negative 3y equals 3. Divide by negative 3, I get y equals negative 1. So the ordered pair here, I was going to write the ordered pair x comma y. It is, but the value, the solution, is 2 comma negative 1. For this bottom one here, it's a little bit dicier with all these fractions. I think the best thing to do is to actually clear the fractions first before you start going through and trying to solve using elimination. So we're actually going to clear the fractions. So this is just a review with that. So multiplying through by 8. So I'm going to multiply 8 times row 1. And then it looks like 6 times row 2. So 8 times row 1 is going to give me, let's see, that's 5x minus 6y equals 2. And then 6 times row 2, so that's going to give me 3x minus 4y equals 6. So these are equivalent forms. These are equivalent parts. So the next part that I'm going to do is I'm going to go ahead and solve these using elimination. This one's a little bit different because I can't just multiply one number per se. I could to give me something that would add or subtract the other. So I'm actually going to multiply the top row. So this is a system that always works. You just may have larger numbers. So I'm going to multiply the top row by negative 3. So I'm going to do the opposite. And then the bottom row I'm going to multiply by a 5. So I need to make sure that one of them is the opposite, because remember, when you add these, I need one of them to be negative and one of them to be positive. So negative 3 times row 1, it's going to give me negative 15x plus 18y equals negative 6. And then 5 times the bottom row is going to give me 15x, what is that, minus 20y equals 5 times 6 is 30. Now when I add these vertically, my x's will eliminate. I'm left with negative 2y equals, what is that, positive 24. Divide by negative 2, and I get y equals negative 12. So now I need to plug this back in. Now, obviously I'm going to avoid this fraction one. Let's pick one of these here to use instead. So this is the one without the fractions, but again, then before I multiply by a larger integer to give us the larger values. So y equals negative 2. I think I'll plug it into the second row. So that's going to give me, let's see, so 3x minus 4y equals 6. I'm going to plug in negative 12 there. 3x negative 4 times negative 12 equals 6. So I have 3x plus, that's 48, equals 6, minus 48 on both sides. 3x equals negative 42. And I get x equals, oh, I knew this at one point. 42 divided by negative 14. There we go. So then I have negative 14 comma negative 12. All right. I'm going to start with this, just the top part, but we'll actually save example 5 for the next video. So this system that has at least one solution, we call that consistent. So if it has a solution, at least one, we call it consistent. If we get a single solution or a single point, then what we have is an independent. If the lines are equivalent slopes and they intersect at all points, then we call them coincident lines. Coinciding, coincident, and one line on top of the other. Since one of the lines depends on the other, we call that a dependent system. So using substitution or elimination will force a statement that is always true. Remember, a statement that's always true, that's something like 0 equals 0, or you get something like 5x equals 5x, something along those lines. A system with equal slopes and different y-intercepts, we get that it has no solution. We call that an inconsistent system. So there's no solution at all. So we get something that's false. So we get a statement that's false. So like 1 equals 0. So we have A, B, and C here. So A is a consistent system. So it's consistent. And because we have one solution, it is independent. Independent. B, we have consistent and dependent. And then C here, this one's that no solution one. This one's inconsistent. And it's just inconsistent. It can't be independent or dependent. There's no solution. It's inconsistent. Join me in the next video where I talk about solving a dependent and inconsistent system. Have a wonderful day.